So I'm Daniel Kahn. Thank you for having me. I'm from Austria. In fact, this is Austria, but I think you know already how Austria looks like. This is my Twitter handle. You may want to follow me, maybe, and I will post my slides afterwards, so you can read it up later. I consider myself to be a full-stack person, so I started around 15 years ago. So I have around, I would say, 5 years to go until my audience was born, in fact, when I started. So when I started, websites looked basically like that. Cats already dominated the internet, as we see. And I did much, PHP and other stuff in the last 15 years, and I would never have thought that I would ever, in 2015, do a talk about JavaScript, and even on the server side at this time we just hated it. Things have changed a bit, so this was what I've done the last few years. This is a startup that uses quite everything, so I had the chance to start from scratch with something, and I just used everything that's funny, so like Angular, Less, Node.js, Play framework with Scala, MongoDB, everything, and I've learned quite much by doing that. And now I'm working as technology strategist for Dynatrace. We are an APM vendor. This means we are doing the same thing like maybe New Relic does. I think New Relic. Who knows New Relic? Who knows Dynatrace? Okay, at least some. We are the market leader, in fact, but yeah, for some reason. And the job, I must say, is quite cool. So I do research on Node.js and all new technologies, and then I go to conferences, talk about this, talk to customers, big customers, maybe like PayPal or Intuit, and then I feed this back into development. So it's quite nice, and this is my company picture. This is because I like my job so much. So I'm smiling. This is how I look like when I go into the company in the morning. So my talk is called Welcome to Mordor, because hunting performance issues is never easy and never nice. And every time, basically, when Node.js gets bad press, it's always about performance problems. So we had this one. This was Node.js in flames at Netflix. That was in fact not Node's fault, but I will come to that later. Or this famous Walmart memory leak that, when you have much requests, it's really a problem. Then really small memory leaks really lead to big problems in your applications. And if this is your startup, hey, you're fine. No problem at all. So you don't have to deal with memory leaks, because those 10 people per day that come, you will restart your server anyway at some point, so it's no problem. That said, Node.js is a long-running process, so it's a difference when you're coming from a PHP background. It works completely different. So every memory you're allocating won't get freed if you don't care about this. But what if you featured on TechCrunch? So you've done your startup. Basically, I think you want people to visit your website at some point, maybe. And then you could basically end up like that. So you are the one person that tries to fix things in production, don't know what's going on. You have 10,000 visitors on your site wanting to pay, and you're just like, how do I restart the server now in a way that I don't lose every customer here? And to understand all those problems around Node.js, I would like to take a little step back and just talk a little bit about what Node.js actually is. And I would say it's a C++ program controlled by V8 JavaScript. Nothing more, nothing less. If you look like that, at that, it's how Node.js is used in the browser. So it was done for Chrome, in fact. And as you see, so there is the Chrome browser and the V8 engine that drives the whole JavaScript thing within it. provides some DOM, the Chrome browser provides some DOM to V8, some bindings, and the event loop. Because when you click on a button and you have a listen on it, something must be triggered, something must handle this event in some way. Let's take a little more step back. I don't know, who knows this chart already? At least some. So Node.js, this is how Node.js looks like. So up there is your code. This is JavaScript. And then you have this Node standard library. This provides every JavaScript function Node.js has to your application, basically. And there are some bindings that you basically need for this, to talk with the system at all. I will show this a little bit later or on the next slide. And then you have this V8 engine. That is the part that actually understands JavaScript in your application. Then you have a thread pool and event loop. These two parts are called libuv. That's one library that handles your whole threading stuff. And I think it gets a little bit easier if you look at this from this perspective. So if you do a require within Node.js, it's basically you're talking with the core library. So require is something provided by the Node core library. If you do a console log, you are basically, I'm missing something here for some reason now. It looks a little bit weird, but it will. No, not there, but not even that. So it's more like here. But I will tell it. It's no problem for me. You have this console log that basically uses system bindings also because you have to log to the console. It's a difference if you do it on the browser because then it's somewhere down there in your browser, or if you do it on the system, what basically standard out of your application is then. And then we are doing this read file. And what we are doing here, we're saying, okay, read in this file. And when you're done with that, please run this, this function then. And this is basically done by the event loop. The event loop will then will queue this, then delegate this to a thread pool, do the whole reading. Your application can do what it does. Meanwhile, answer other requests, and then when this file is read, the main thread will be pinged by the event loop, say, hey, I'm done, here is, please run this function with this data, and then you proceed with that. This is how Node.js basically works every time. Here we are. So, and if you look at this, it's always that we basically feed this whole Node.js JavaScript code into V8. And what V8 then does, it compiles it down to machinery code, basically. So it's not even bytecode, it's a pure assembly that runs on your system then. And I would say that every running program is basically represented by something that's going on the CPU and some state that's stored in memory. And if you look at the memory of such a Node.js application, it's quite interesting here, because here we have everything that's allocated by Node.js is called residence set. And this is the memory your application uses. And then we have this code segment. This is basically the, what you wrote in your program. Then we have some stack, local variables and pointers, and then we have this heap. Here we store objects and closures and everything that's big and everything that's dynamic. And then we also have this used heap. So Node.js will allocate basically a section of heap, and then there is just a fraction that is actually used. And it's quite easy to basically ask Node.js how it is doing with memory. You just have to use process memory usage to get this, and then you will get something like that. That is quite the same as I've showed you before. So residence set, heap total, and the heap used. If we have metrics, we can always graph it out. And this is what I did in this case. So here we have our residence set. This is the total heap, and this is the heap used. And as we see already, there's something going on here. So we see this is, quite an unsteady thing. There is heap allocated and deallocated all the time. So there is much going on in the application. And still we see that when we do a median through this curve here, we still see that we are the total usage stays quite constant. And if we take a little step back again and look how we handle memory, maybe in C++, it's always like that. We allocate some buffer, then we do something with this, and then we tell basically the runtime to free the buffer again. Now, as we said before, here I have funny callouts also. And as I said before, now V8 basically handles all your code. So there is no way, and the data structures you use in JavaScript have nothing to do with the data structures within V8. So there is no sane way to tell V8 or Node.js, now please free this variable, free this memory, or do a garbage collection or something like that. And so we need some way to remedy this, and this is why garbage collection basically exists. This is an Austrian garbage collector, basically. And garbage collection is also, I would say easy. Who knows garbage collection from other languages? Yeah, quite a few. So what Node does, and that's the same, or better, let's say V8 does, because every time we're talking about memory in Node.js, it's always V8. So this, what I'm telling you now, also applies to when you use JavaScript in the browser, by the way. So what V8 does basically is, it's just keeps track of which objects do exist and how many other objects are referring to this object. So it has the assumption if an object has no incoming path, then we could say, okay, no one needs this object anymore, and then we can dispose it. I can show you this a little more graphic here. Yeah, here we have maybe an object, and there we have, let's say this is a big string, and this object is referencing to this string. And then we have maybe another object, and there is another, and this one is also referencing the string. And they are all in some way interconnected. We see already it can become complicated, and we see already what this data structure basically is. It's a graph. So we have nodes, we have edges, it's a graph. And we see now we have 3 incoming paths into this object, so it cannot be freed by the system. To free it, basically we have, if we take this away, nothing will happen. If we take this away, nothing will happen. Still nothing, and it will still stay in memory. Then we take this away, and finally the garbage collector says, okay, hey, no one is using the string anymore, so we can easily dispose it. And I don't want to go into deepest detail here, but there are 2 types of garbage collection, basically. One is called scavenge compact. It's like say, you go with the thing and just clean up a little bit, but not too much. Just do it quickly. And there is this other thing. It's called mark sweep. This is like, okay, now really look, where are the objects, go through the whole memory and really clean up everything. This is because every garbage collector run basically lets your program run into an interrupt. This means that the whole process will halt here. So it's kind of a time penalty you have here, and it should be. It's always the system always tries to do this quickly, and that's the reason why we have different stages of garbage collection, basically. And even this can be graphed out using Node.js profiler, and Node.js profiler just exports. It's a module, so you can. And I also, when I post my slides here, you have also links to some gists by me that you can use to try it out at home. So Node.js profiler does nothing else than subscribing the garbage collection events already provided by V8, in fact. So this is no magic. I think the code of this module is around 200 lines of code, so nothing. And I use this to also graph this out, and we see again, okay, we have here this Max sweep runs. They are heavy and they happen rarely, but also in some frequency. And then we have this scavenge compact runs that run all the time in your system. And this is, as we see here, this is more or less the sawtooth pattern you've seen before in my memory graph. And then there is this, this move down of this chart, and this is basically that. So these are the sawtooths, and every time the Max sweep runs, bam, you're back to normal with the application. So we have a garbage collector, the memory is freed, everything is nice, I think we could go home. This looks like a happy end for me. Unfortunately, life is no Disney movie, basically. And to understand the problem, we have basically wheat, meat, Linz. This is where Topconf, the next in Linz, will take place there. This is where I live. This works better in the US, I must say, because the house where I live, was built around 60-40 something, and I can tell them, look, my house is just 150 years younger than your whole country here. And yeah, that's where I live. And there is a room there. It looks like that. So this is a room when I leave my flat, then I see this door. And in there, this is the room, everyone knows this, there is the room where the garbage lives. And once a week, garbage collection people come and take this away and everything is good. But we have those stuff in there for, I would say, years. And what you see here is, they write here, bitte nicht hier abstellen und gleich selbst entsorgen, which means don't put it there, please put it away yourself, because no one else will do this, basically. Yeah, and that's where the problem starts with garbage collection in Node.js, because it's quite the same. So suddenly, you might find this in your log file. So your process will stop, and you will see, oh my God, we are out of memory for some reason, and this is what I did. Here we have this scavenge and Max sweep stats again, and yeah, I don't know what's happening, but it means that my application just died. And you are smart, and you have this process memory metric thing in mind, and you just kick this thing in, and you see this. This doesn't look good. You see, now we have here our trend line steadily going up. So something is wrong here. You see that the garbage collection is in fact working, but for some reason it just can't free everything up what's in there. And this is then where you spend your weekend, because you have to find this problem in some way. And what if we would have a way to just look into the memory and see what's going on there and see what's allocated there, basically. And there is a way, and it's called V8 Profiler again. You can use Profiler Take Snapshot to really take a snapshot of your current state in memory. And this is, again, the same thing you could do in Google Chrome. It's a pure V8 function you have here. And yeah. And to kind of demonstrate this, I've built a little memory leak. And the interesting thing on this leak, so you could build your own memory leak very easily. You just have to decide you want to store every IP address of every visitor in a global array in your Node application, and yeah, you have a memory leak, but that's way too easy, I would say. Here it's a little bit more complicated, and I have also a blog post about this, so I will kind of go through it a little bit quicker. What's happening here is that basically we have here a closure, and the thing about closures in JavaScript is that it needs the scope of the enclosing scope, so it sees this unused function that's in fact never called, and sees there is original thing here, and original thing again points to this variable here, and the thing basically points up there, and there you have this thing that contains a really huge array of asterisks. So, and this is in fact no bug in your application. So this is completely sane code. Just V8, the garbage collector here, just gives up following all the indirections you just built. And if you have this in your code, you will have a really, really hard time to in fact pinpoint the problem here, because yeah, it looks sane basically. And what you can do now, and I've shown you before, you can just take CPU snapshots, and to do this right, you have to basically take snapshots for a certain period of time. So one snapshot won't help you. I will show you them. So a good idea would be to just create a little script that runs with your code, does this process memory metrics, and looks, okay, is there something steadily growing? That's what we call anomaly detection, basically. It's like finding out if something is weird in your application. You can even correlate this then with visits, and so you can build your own little performance monitoring here and find out, is this process still acting sane in some way? And what you will get then, and I've prepared something for you. I just have to bring it on the screen. Those live things are always the dangerous parts of presentations, but I do my best here. So here we have it. So what I did, and I have also a code example in my slides. I've had this application with this memory leak in there, and I take a memory snapshot when the application starts, and then after some time, and then after some time again. And I have 3 heap snapshots here now. And I take this one, and this again won't help us much because, yeah, what do we know about the application and what grows in fact? To know if something is growing, basically you should have a delta in some way, and this is what Chrome developer tools, yeah, this is Chrome developer tools. You have it, when you have Chrome, you have it on your system. We can do a delta here. So I go to comparison up there, and let's just compare this one, 64 with 29 maybe, and this doesn't work. So, okay, and then we see, okay, there is this string object constantly growing here, big time, and maybe let's look into it. And here we have our string, our asterisks we just have allocated there. So it's not always that easy, for sure, but that's the way you can, and that's basically the only way you can trace down and debug memory problems in your application. And there you see also what's going on there. So we have a really, those context objects we have here, this is the context of the closure I just showed you. And we have, you see here that we have a really, really deep nested structure of nested references in your application. And this is causing the memory leak. And then, if you have done this and found the problem, it starts from this. Now, this is what I don't want. 1 second. Stay with me. So, here we are. So, yes. So we can simply do the thing equals null here to let the garbage collection know, okay, this object is really not used anymore, and then we're done. So your weekend is basically saved when you're doing this. One question remains here: have we solved, or could we solve this Walmart memory leak I was talking before? In fact, no. The problem is here, maybe you could, but you have to be very, very good to do this. The problem is here that the bug was caused by this little missing line in C++ within Node's core. And there was just a scope declaration missing, and so it was assigned to global scope, which means that these variables live for the whole process lifetime, and this leaked around 4 bytes for every request. That's not much for regular applications. For Walmart, this was quite much. And my take on that is, okay, we can introduce so much problems in our own code. Let's just think that if something goes wrong within Node's core, there are enough smart people around and big applications around that this gets fixed quite soon if it occurs, basically. So just for you to kind of relax for a short time, I'll show you a cat with no special purpose. Let's revisit this again. There was this blog post by Netflix. It was called Node.js in Flames, and they were kind of blaming Node.js because, for some reason our response times go up all the time, and then we have to restart our processes every time to get back into sane state. The reason basically for that was that they had some script running that automatically added express routes. And they were assuming that the routes always consist of a pass part and something that's happening in this route then. And they were kind of assuming that this path part is like a hash map. So if the same path comes into the system again, it will just overwrite the other one. This was wrong, because in Express the same paths can exist and there are even regex paths, so it isn't possible to do this with a hash map. And that was the reason then that they have run into this problem, and then they had this Node.js in Flames blog post, which caused the flame war afterwards again. And here I have the thing I just wanted to show you before, but now I have it here, but no reason. We talked about this before. So there's something is going on the CPU. If you do a read file here, it runs on the main thread, then to the event loop, then to the thread pool, to the system, and then it will ping back. So, and if you decide to maybe calculate Fibonacci in there, you have a problem, basically. Because this runs on the main thread, and the main thread is the thing that basically will answer every request even coming into the system. And if you calculate Fibonacci here and it takes 10 minutes, then your system will not be able to answer anything for 10 minutes. Unless you use clustering, then yeah. But then you still have big problems. And the way to track down CPU problems mostly looks like that. So you do, and this also resembles my Lord of the Ring topic in some way, because it looks like Mount Doom to me. These are basically flame charts that will show you what's going on your CPU. And I cannot read them. I just have some problem with that. I don't understand that well, but there are people around that really like to look at flame flame charts, I do not. So it won't explain any more about them, but I will show you a different way to graph out your memory. There is a thing, again, V8 profiler, and it subscribes to profiling features provided by V8. And so you can just create a CPU profile of your running application and really look into what's going on your CPU. And what you will get back then is something like that. And this looks weird, but it's quite easy. It's basically a tree. It's just a data structure in JSON that you can use to work with. And I created a little CPU hog, a prime calculator that does weird things. And I can show you this again now. Here we go. So I just don't know if it, yeah. So we have this application, you know something is slow, something is consuming CPU, and you can again use the data coming out of the CPU profiler and just load it into your Chrome developer tools. And this is again a very graphic example, but it works quite well because you see up there we have our prime calculator up there, and it's just in this CPU snapshot, it's the heaviest thing running on the CPU. And this can help you to pinpoint hotspots that cause your applications to be slow. And there is another way to just kind of visualize this thing. 1 second. Here we go. Yeah, this is kind of the same thing. Chrome will provide this to you. This is from a running Express applications. I can't make much sense out of it, but still, this has its purpose. I'm too stupid to understand it. What I use to understand the thing is D3 basically, because I have a JSON structure that resembles a tree. What can I do with it? I can feed it to D3 and just let it create a sunburst chart. And I have a little really nice example for you here. I found out that who uses Express? A few. You can run Express, a Node.js framework, with the environment variable set to development or to production, and it will default to development if you don't set it at all. What this means is that your template engine will compile all the templates for every single request. And what this consequently means, and you see it here very, very clearly, how much more there is going on your CPU here. So we are talking about it's half as we lose around 50% of performance in the application if we don't set this. And this is kind of, I think it's stupid because it's so implicit within Express somewhere hidden in the code. If there is no Node.env set, then just switch to development, and this causes side effects all the way down. So this is something to consider, and I'll show you how we could. Yeah. So how do I get this on the screen up, down? Here we go. So, yeah. And this is a quite nice example because, yeah, I fed this to D3 and I can really scroll, hover over it and see which functions are running here. And we see every time in this real big block, we see it's always Jade in some way. And then we can say, okay, something is going on with Jade here. What's happening exactly here? And even nicer, you can go in there. And that's just nice to show it to the business people in your company, because you can click in there and it will drill into the whole thing. And then you can again look into what's going on exactly in this thread, not thread in a threading way, but in this tree part here. Okay, so here we are. So let's just put this all together. So we have process metrics, we have a V8 profiler, we can get memory usage from the process, we can get heap dumps, CPU dumps, and then we have Chrome developer tools. Why not just create your own monitoring dashboard, basically? This is easy to do. Everything I've shown you here, you can trigger it from code-wise from a running Node.js application. If you do this monitoring dashboard, you can just build something that will help you. If everything breaks in production, you have a way to just enable those metrics and look, hey, what's going on exactly in your system. And while you're in development, I would strongly recommend you to just do load testing, basically. And there are lots of tools around, so I just look at the slides later, but you can even use AB. It's on I would say, every Mac has a patch bench installed, and you can hammer your application and just look what's going on if I do this. That's really, really easy to do. And this will maybe help you then to pinpoint problems in the future. Yeah, that's it so far. Slides, blog, tweets, I don't know if you know, but we conference talkers basically get paid by Twitter followers we get. So when I come home without Twitter followers, you know. So I don't want to eat pasta next month again, so please. Thank you. We have 3 minutes left for questions. Anyone?
I have a question about this P3 thing. Is this something you put personally?
No, it's a JavaScript charting library. Yeah.
How to get the profile into this chart?
It was completely easy. I was looking up sunburst chart D3, and such a code example came up, and I just kind of adopted it. I don't know, maybe it's even in my slides, a link in there. If not, I will put it in. It's just a few lines of code to make it look like that. Was it interesting for you?
Of course,
yes. Okay. So then we are done, basically. Thank you.